Okay, hello guys, my name is Brooke Middleton and in this video I'm going to be teaching you more about mass percent. Okay, in this video I'm going to be doing 3 different questions and my third question is going to help you learn the difference between molar mass concentration and mass percent concentration. Alright, so let's get started. Okay, question number 1. Terry needs to prepare 5% of sodium chloride solution in water. What mass of sodium chloride does she need to prepare 75 grams of solution? Okay, so first, whenever you're doing these type of problems, you want to break it down. So in this problem, they gave us the mass percent of NaCl, which was 5%, and the mass of the solution, which is 7 grams. Okay. The goal is to find the mass of the solute, which will be X. So whenever I'm trying to figure this out, and you're probably like, oh, which one solute, which one solution? Like normally in these problems, that's where people mess up. I know that's where I used to mess up. So what you would do is you would break it down. You say NaCl is the solute, and H2O is the solvent, and NaCl aqueous is the solution. And whenever we're going to be doing this problem, we're going to be using the mass percent formula / equation. So it's the mass percent equals the mass of the solute over the mass of the solution times 100. Which is very important. Make sure you always multiply by 100. Okay, so the given is 5%, and which we're going to change it to a decimal, which is 0.050, because whenever you're doing percent, you go over to the right 2. So if you do a decimal, you go over to the left 2. Okay, so then, and also 75 grams of NaCl. Okay, so, yeah. So whenever I'm setting up this equation, I would do 0.050 equals X over 75 grams of NaCl aqueous, which is the solution. So whenever I do this, I'll just multiply by 75 on both sides to get X, which is the mass of the solute. Okay. So question number 2. Sarah will prepare a 1% potassium nitrate aqueous. What mass of water should she add to 10 grams of potassium nitrate? See, this question also had me wondering. I was like, oh, this is kind of confusing. I was up like for a few hours trying to figure out how do you even solve this equation. So what I did was that I first just do what I always do. Find the givens and the goals. And the given was not like the givens were not like the other question that it just had about tearing. This one, the given is the percent by mass, the mass percent of KNO3 aqueous, and then you have the mass of the solute, which is 10 grams of KNO3. So instead of like the other problem, you had to find the mass of the solution. This time you're going to have to find the mass of the solute. So what I would do is first set up this equation. I always set up this equation so I know what I'm solving for and what I need and figure out how to plug in the things they gave me. So KNO3 in this this problem is the solute, and KNO3 aqueous is the solution, and H2O is the solvent. So here's the tricky thing about this problem. Most of the time, like, people would probably just solve for X and that'll be the answer. But in this problem, it says Sarah will prepare blah, 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 blah. But what is the mass of the water? Okay, so whenever you're doing other problems, you have to make sure you know what you're trying to solve for and make sure you actually solve for that in the end and don't get distracted. So whenever you're doing solution, the solution is the mass of KNO3 or the mass of any compound that you have plus mass of H2O. That will equal the solution. That's why it's aqueous, because it's soluble in water. Okay, so in this problem, you take the mass percent equals mass of solute over the mass of solution, just like any of the other problems. And so in this one, it was 1%, so I moved it over to get 0.010 for the decimal. and I put equals 10 grams of KNO3 because in the problem they gave us 10 grams of KNO3, not the KNO3 aqueous, but the KNO3. So then once you get that, you would solve for x. So after you solve for x, you minus 10 because 10 grams of the solution, 10 grams of KNO3 was in the solution. So if you subtract that number from, subtract 10 from that number, then you get the mass of the water because that is what's left. Okay, question number 3. How is the mass percent concentration different for the molar concentration? Okay. So molarity, for the molar concentration, you're going to be focusing more moles over the solute or moles over the volume. So then, like we do in class, it's M equals N over V. And the mass percent equation, it's the mass of the solute over the total mass of the solution. See, the difference between these two is that this one's talking about volume, and this one is talking about the mass in grams. So, as you can see, molarity relates to the amount of solute to the volume of the solution. Mass percent refers to the concentration of an element in a compound. So, yeah. So just make sure you know that, and usually in the problem, it'll be easy to see. You'll be able to say, oh, they're telling me they want to find the moles. It's not based on mass, so I can't do mass percent. You just have to think about that. And, yeah, so that's the video for today. I hope you like it. Yeah, thank you.